Okay, so now we have a sense of how these log functions sort of look in an algebraic sense. Now let's see what they actually look like in a visual sense. Let's start graphing the log function and get a sense of how it looks visually. Okay, so let's begin with sort of a standard looking one. How about if the function f of x were to be log base 2 of x? And I want to know what that graph looks like. Okay, well, what can we do? Well, one thing we could do is just plot some points and get a sense of what this thing looks like. Now, it may be good for you, or it may be easier for you, to sort of write the converted statement just to sort of help you. So a log is an exponent. So that's the exponent that I have to raise 2 to in order to get x. So basically, this would be x equals 2 to the f of x. This may help or may not help. It certainly helps me. Let's make a table now and see what this would look like for different values of x. It also will help you pick some easy values to plug in for x. For example, what if I put in a 1 for x? Then what power of 2 will give me 1? Well, the answer is 0. Okay. What if I put in a 2 for x? What will this have to be to make this thing equal to 2? 2 to what power is 2? Well, that's 1. 3 would be an unfortunate choice for x because it would be hard for me to figure out what this equals. But 4 is good. If I put in 4, that value must be 2. Because 2 squared is 4. What about some negative values? Could I put in negative 3 here? Well, I could, but of course, there is no power of 2 that will give me negatives. So forget about negatives. So in fact, this graph will not go into the negative side of the x-axis because it's just not defined there. The domain is going to be positive x's. So but let's try some small values. For example, what about 1/2? If I put a 1/2 in here, what would this function have to be? 2 to what power equals a half? Well, 2 to the minus 1. So in fact, this is negative 1. And 1/4 would be negative 2, and so on. So let's start to put this together and see if we can get an accurate picture for this. Let me just move this over for one moment. Let me create a little axis action. One little axis action. Okay, there's an axis. Now I'm going to start plugging these points in. So here we go. 1, 0. So I go 1 unit over and then 0. So let me do this in a different color. Let's use this color here. So 1, 0. It's right here. Then 2, 1. So I go 2 and go 1 unit up. Go here. 4, 2. So 1, 2, 3, 4. And I go up 1, 2. Okay. And then at a half, I go negative 1. So at a half, I go down to negative 1. And think about it. A 4th, which would be right over here, would be negative 2. So it's way down here. So you can see what's happening. I get a curve that looks like this. It grows very slowly. It's increasing. And it comes down like that. And that's the log function base 2 of x. Notice, by the way, that if you turn your head this way and look at the picture and flip it, it sort of looks like an exponential. Well, that's because this is going to be the inverse of the exponential we'll see later. But for now, notice that it has that same shape. It's increasing, but now very slowly here. It's going up. But here it's actually asymptotic to the y-axis because, in fact, there's no value for x which will make that 0. And so we have a vertical asymptote here for the log function that looks like this. Okay, all of this by plotting points. Now, what if we take a look at another function? How about if I look at a function, let's call it g of x. Suppose that's log base 3 of x. Okay. Well, let's see. It's going to have this basic general shape, but the question is, what happens when I put a bigger number there? Is it going to sort of go up or down, or how is that going to interact? Well, let's just make a table of a couple of values and see. That's the easiest way to do that. So let's take a table here. First of all, you might want to convert this, if that is your pleasure, to see that x would equal 3 to the g of x. That's what this is saying. So I make a table x and g of x. Let's just plug in a couple of points really fast here. For example, if I put in a 1 here, 3 to what power gives me 1? 0. If I put in a 3 here, 3 to what power gives me 3? Well, that's 1. If I put in, let's say, a 9, this would be a 2, because 3 squared is 9. And then finally, let's just put in like a 1/3 and realize that's negative 1. Those points should do it since I know the general shape now. I'm getting better at that. Put these here. And let's graph these points. So at 1, we're at 0. So this point is a common point with the previous graph. Then at 3, 1, 2, 3, I'm going to be at 1. So now I'm going to be only up here at 1. At 9, I'm going to be at 2. Remember before, the previous thing, at 4 I was at 2. Now to get to that height of 2, I got to go all the way over to 9. Look at that. What's with that? So 1, 2, 3, 4, 5, 6, 7, 8, 9. I only make it to 2. So this is growing even slower than the first one. But at 1/3, I'm at negative 1. So what I see here, at 1/3, I'm at negative 1. So I see a curve that looks like this. It undershoots here, but once it crosses the x-axis, it then overshoots, and it goes right down there. Now, it's hard to see that maybe in this picture. I'm sorry. But in fact, let me just enlarge this maybe to show detail, just so you can see that little piece right there. This is sort of important to see how the two things work against each other. In the first case, we have this kind of picture. And in the second case, we have this picture. I just want to show you how these things sort of meet up. You see, they crisscross here, and to the right, the purple wins. So the smaller base wins out. But then, this is log base 3 of x. But then, when you go to the right of 1, you see, then the red, then the higher power wins out. So this is sort of on top for a while, but then it's on the bottom for the rest. Okay, neat. So there's the graph of log base 3. How would log base 10 go? Well, now I think the pattern is pretty clear. For log base 10, the higher the power, the slower this part goes, but then it goes up in front here. So log base 10, still smooth, no creases, but just it would look like that now. But again, remember, it's still asymptotic. So even though this picture is really awful, it would still just be asymptotic, just like the purple, but it would be always between the purple and the y-axis. It would always fit in between the purple and y-axis. This would be log base 10. So you get a sense of how this looks. Let's just do one last one to really muck up the works. So to muck up the works, let's try this. Let's try h of x, or I'll call it m of x for muck. Mucking up the works, we'll look at log base 1/2 of x. What if you have a number down there that's 1/2 instead of just being, a big number? Well, what would that do? Well, if you convert what that means into an exponent, what you see is what? X equals 1/2 to the m of x. And if you rewrite that, you'd see x equals 2 to the minus m of x. So basically, what I'm going to do is I'm going to have the same graph as this, but now I'm going to have a negative exponent, and what that does is basically flips along the x-axis. Because notice, for example, if I plug in, let's just plug in 1 point here, for example. Let's just plug in x equals 2. If x equals 2, then what would m have to be? M wouldn't be just 1 like it was before. It would have to be negative 1 to make up for the negative sign in front of this. So then m would be negative 1, because 2 to the negative 1 is 2. So you see what happens is this point that used to be 1 is now going to be negative 1. And so this point that used to be 2 will now be negative 2. And this point that used to be negative 1 will now be 1. So in fact, I get the exact same picture as the purple, but it's going to go reflected over the x-axis. And so this is what the log function looks like when you have a base that's a number that's between 0 and 1. The log function looks like that, sort of the mirror image of this one. However, when you have a log of a base that's bigger than 1, it looks like this, and the bigger the number, the more sharper it turns. So if you want to graph this function, the first thing I would do personally would be to graph this, and notice it's just a flip over the x-axis. think about this, work through it, plot a lot of points, and you'll see that, in fact, these are the graphs. Enjoy.